Okay. So if you're trying to derive the double angle identity for sine 2x, sine 2x is the same thing as sine of x plus x. And if you use a sum identity, which I will give you, replace the u and v, or a and b, sorry. You replace a and b with x and x. And these are identical expressions, right? So you can combine it like this. Pretty simple, right? How about cos 2x? You write as cos of x plus x. So it's going to be cos x times cos x minus sine x times sine x. And that can be consolidated like this, right? Now, there are two other variations of it. I'll do that in just a moment, because that will lead us to the power reducing identities afterwards. Then how would I derive the tan 2x? That's the tan of x plus x. And using the sum identity for that, that's tan x plus tan x over 1 minus tan x times tan x. And that could be consolidated like this: 2 tan x over 1 minus tan squared x. Yeah, what's up?
You give us the sum and difference for all three of them?
Yes, they'll be on top of the test. I'm copying and pasting the Word doc, keeping that there. Okay, so that's how you do the double angle identities. Now let's focus on power reducing. And just realized I can't really lasso this, but let's see if I can. Probably save this. Upgrade. That's lame. Whatever, you guys get the idea. So I'm gonna go and clear this. No, okay. Actually, hold on. There's another way I could share. No. Yeah, I'm just gonna do that. Good call. Okay. Let's go. That's up. We're gonna do that right now. All right, let me trash this. So cos 2x was this, right? You do need to know your Pythagorean trig identities, which is just really Pythagorean theorem. So you could say it's this. Or you could say this. That's when you replace cosine squared with 1 minus sine squared, or sine squared with 1 minus cosine squared. Now let's focus on this guy. Okay. So cos 2x equals this, right? So you add 1 to both sides. And divide by 2. And then square roots. Mouse space there. Hopefully you guys can see that. All right. So sorry, cos squared x. Wait. Oh, let me back up a little bit. Let me leave that for now. I'll do half angle in just a little bit. I'm getting too ahead of myself. Okay, we're cool with that. That's power reducing, because you're reducing the power of cosine squared, 1 plus cos 2x over 2. Okay, that's power reducing. How do I get the other power reducing? I use this one, right? So cos 2x equals 1 minus 2 sine squared x. So if I move the sine squared x to the left side and do this over here, divide by 2, and then square root. No, leave it like that for now. That's the other power reducing. Sine squared x equals that. And how do you get tangent squared? Just divide those two. All right, that's how you get tangent squared. So you do 1 minus cos 2x over 2 divided by 1 plus cos x over 2. You flip the 1 plus cos x over 2, and you get 1 minus cos 2x over 1 plus cos 2x or tangent squared x. Okay, so that's how you do the power reducing identities. Lastly, the half angle identities is done like this. So you have cosine squared x equal 1 plus cos 2x. So you can square root both sides like this. And then if you replace x with x over 2, then the other side, you replace 2x with what? Just x straight up, right? And you do likewise for sine squared x. And then, of course, do that. If you want tangent, just divide the two. Or take your tangent squared x, your power reduced for tangent squared, and just replace x with x over 2. Or just square root afterwards and then do that. And so you wind up getting this, right? So that's how you derive the rest. So now you have the flow. And I just realized I didn't screenshot the other one, so I'll also have to undo my writings. So let me screenshot this one. And hold on. All right, so why don't you guys use the rest of